So our next workshop will be presented by Emily Godson. Emily is a senior data analyst for Hitachi Vantara, and she's currently the lead data scientist in a digital hospital project for a large NHS teaching hospital in the UK, where a range of machine learning models were developed for demand and capacity planning. So Emily will present the workshop Data Science in Healthcare, and please welcome Emily.
Yeah, so thank you very much, Julia, for the introduction. As Julia said, I'm a data scientist working at Hitachi for the last few years, working as a lead data scientist on a healthcare project here in the UK. So my presentation is on the data science in healthcare. So we'll talk a bit about the challenges that are in both the healthcare and building data science in healthcare, and then how we might go about tackling building a data science project and some of the ethics and Q&A, and then leave some time for a Q&A at the end. So data science in healthcare, this has been kind of a big popular field in recent years, and I think part of the popular uptake of this is partly to do with the digitalization of records. So a lot of the records in hospitals, GPs, are starting to be digitalized, and there's a large amount of data there ready to be used. And also we're starting to see more and more digital data coming from things like sensors or scans or wearable devices. So, you know, all the kind of watches, digital watches and things that collect large amounts of data about people in general. And so all this data altogether combined provides a diverse range of data, and from that potential topics for data science. So there's a huge range of data available to start doing some data science work on. And we're going to go through a few examples of areas that data science is currently being applied, just to get kind of the juices flowing about the art of the possible. So there's some kind of patient-centric ones, so around things like early detection to diagnosis, so earlier detection of potential disease or diagnosis of any kind that a patient might have. If we're able to get an earlier diagnosis, that patient can get earlier access to treatment and might get better outcomes. So data science is really kind of helping in this section to kind of provide better outcomes for patients. There's also things like risk stratification that can identify patients that are kind of at higher risk of either complications or you know, disease progression, so that they can access the right care and you know, in a timely manner. There's things such as symptom checkers, which people might have used, that you kind of put in some of the symptoms that you're having, and some of those tools might use data science to say how to predict what it might be the problem. And then there's things like medical imaging and diagnostics. So thinking about kind of computer vision, we get lots of images taken in the healthcare setting, like X-rays, MRIs, etc. That's just a few. And there are some data science models in the area of computer vision that can be used to create diagnostics from those. Okay. So we've thought about the patient. There's also things within kind of, if we think about the healthcare system as a whole, that data science can be applied on. So things such as patient flow solutions around where a patient should be, when they should be there, and how they might flow through the system, be that a hospital or around community services, and all that kind of patient flow to help the smooth running of the service. There's things such as demand and capacity forecasting. So what's the demand going to look like in the next few hours, and thinking about how that affects your capacity in the service that you're running, so that staff can proactively plan and prepare for the demand they're going to see, so that they can, you know, start to try and proactively resolve something that they might be seeing upwind in a later time period. And then it can also be used for things such as identification of staffing requirements. So how many staff am I going to need, at what time, where, what sort of staff, to match kind of the demand, or to match what the trends are showing might be required. So data science can really help in this area, to help with the whole system efficiency. Another kind of another kind of area that data science can impact is in kind of knowledge generation. So if we're thinking around drug discovery, how data science can help there, and it can, it might help with target validation, or it might reduce failures of clinical trials and such. So it can be used in a lot of spaces there. It might be used for to understand a bit more about rare diseases. We can look at things like look at correlations and understand some of the relationships that are present in some of the historical data for patients with rare diseases. We might do some pattern recognition, so looking at kind of, we might be able to identify patient subtypes, or kind of disease progression as it goes along, as it progresses in a patient's life cycle. And then a greater understanding of causality, so modelling and understanding the causes of something. So instead of just looking if there's a correlation, we would want to look at the causality to understand if X causes Y. And then the final kind of example that we'll just touch on lightly is kind of public health. So thinking kind of wider scale, so digital epidemiology. So that's kind of the patterns of disease and health across the whole kind of population. And then national screening programs that might use some, if there's some data science to identify certain cohorts of patients, or identify a condition, applying that across a national screening program might identify some additional patients. And so we've spoken briefly across a few examples of where data science might be used in the healthcare industry, or where it is currently used. And so we can also think about what challenges are faced in the healthcare industry at the minute. So things such as capacity. So there's more and more demand in recent years, but also because of things like COVID, there's increased backlogs, increased waiting lists, which create bottlenecks for delivering care. And so this is a big challenge in healthcare at the minute, as we think about system efficiencies. In particular, capacity is one of those key ones that might be required to be made a bit more efficient, or improved on. There's also the workforce. So there's, because of this growing demand and capacity problem that goes with it, we also have to think about the workforce. The staff retention challenges in the healthcare industry at the minute, exacerbated again by COVID, which puts a great strain on our workforce. And both of those kind of capacity and workforce lead into performance. The cost of care is also going up. So being able to drive improvement and help in any way that we can with data science is a really a big challenge that might be useful to apply data science to. And so when we're thinking about some of these challenges, we might also want to think about the challenges that if we start a data science project, there might be some challenges that go alongside that. So first off, data is always the kind of the starting point of everything. But if we think about our data for healthcare, then there might be some challenges around data interoperability. So if I think about how I might access the healthcare industry, I might go to my GP. I might have data also at my old GP. I might have data at a hospital. Sometimes, getting access to all these sources or joining them together can be a challenge to get that full history. So when starting a data science project, you also want to think about what data you need, where it's from, and some of that might be with stakeholders or just from understanding the problem. Once we have our data, we also want to think about the evolution of healthcare. So it's always evolving, there's always new treatments, new medications. So when we are looking at our data, we have to remember the time component of it. So data that from 10 years ago around a good treatment might be different to the picture that we see at the minute. So thinking about the time component of our data when we are analysing it is a key part of data science in healthcare problems. We also want to think about the different types of data that we might get for healthcare problems. So you might have a mix of structured and unstructured, so different sources. Some might still be paper, some might be digital, which is always great. There might be images, videos, and other files that could be used, and make sure that we have the right skills to understand those data to get them as much as we can from it as possible. Once we have the data, naturally healthcare data is quite sensitive, so you have to consider the privacy requirements required for when you're looking at the data. You might not need some patient sensitive data. It's unlikely a model is going to need a name, so you're never going to need those sort of things. But also there might be other we just have to make sure that some of the IDs and things, they might have different privacy requirements. And so for healthcare organizations in particular, they have some governance and some restrictions that they might have, such as like HIPAA or GDPR, to name a couple. There's lots of other ones. And we talk about this idea of privacy, and so we can name off a few easy patient details that we probably don't need, but also that would lead to us identifying a patient. But it also gets a little more complicated when you think about that actually some of their data might also make them identifiable, such as, if someone has a rare disease, there's only a handful of them, if you know their diagnosis and their age or geographic location, you might be able to narrow it down to a single person. So you have to consider some of those details. If you were able to piece all the things together, do you have the right security available? And so we've spoken a lot about the an introduction into data science and healthcare, the challenges and how we might how we have to consider those. And so then we might think what goes into making a data science model. And so we can think about it in a traditional sense of a data science problem around problem review, understanding what hypothesis this model is aimed to solve, what approaches might be useful to go to start with, and starting to explore the data, and then moving into the resolution phase around preparing it for modeling, any feature engineering we might do, and any model development again. And it's an iterative process, as it can often be with data science, and then deploying to the model so that it can be used, and then embedding it into the customer or location that's going to be used. And so we'll go through each step a little bit more in detail. So problem review. So you have to think a bit more about the hypothesis that we're going to use, what you're trying to improve, reduce, or optimize, what is the business value of applying data science, does it need to be data science? Sometimes data analysis might be the correct, just surfacing some data or doing a piece of analysis. Or sometimes a model is the correct is the correct kind of way to go with the model. So making sure to consider all options. Especially in healthcare, we also have to think what are the risks associated with the model being wrong. So what is the risks if we have false positives, or what is the risk if we get false negatives, if we predict false negatives, because and naturally it depends kind of what your model is solving. But, some of these would have big impacts on, could have a really big impact on patients. So you have to start to think before even starting, like, what are the risks if it is wrong? And understand that with your kind of stakeholders that you might have from the healthcare industry. And so once we've thought about all of these things, we might start to think about our data again. So what data do we need for the predictions, and also kind of what level of confidentiality do we need? So is it identifiable data? Could we actually use anonymous data? That would reduce some of the risks of having this patient data. Or can it be synthetic? And that's synthetic based on like the distributions of the actual set or of that type of data, but could that be used? And in some cases it can be, or in some cases it might be just anonymous data that you use. It's kind of case by case. So once we have thought about our problem and we're ready and we've got our data, we can jump into some data preparation. And so, as always, we probably do some exploratory data analysis, understand what data we have, understand some of the relationships. We might want to understand some of the quality. So the quality, is it an accurate data? Is there is it text? Is it what features do we have? But we might also want to understand the missingness of the data. So sometimes we might see that the data is got a lot of nulls, or it's not got very many values. But we also want to consider what type of missingness that is. So in healthcare data, and also in others, but in this case, healthcare data, some of the values might not be filled in based on a process, so missingness not at random. So for example, blood sugar, say this is not recorded in a triage setting. So when someone is being assessed, we might the medical staff might not take a blood sugar level, but when we speak to them, that might be because they well, it wouldn't be useful for what that patient has come in for. So, they might just take blood sugar if they think it's diabetes related. And so actually that data isn't there because of a process. It's not missing at random. It's kind of missing as part of a process. So that's actually quite useful for our model as well. So we have to try and think about what that missingness tells us about the feature. And we also want to consider that actually our data that we get, usually, and not always the case, is a snapshot of data. So it's a point in time. So we have to understand whether that data, when that data is generated, is it all generated at the same time? Is it retrospectively added? So things like diagnosis codes are kind of done after a patient has left, usually. So it's not available if we're doing any predictions during their time there. So And that's why it's really important to understand kind of the data generation process as well. Make sure it's going to be available and complete at the time that we're wanting to use it. And so once we've prepared a whole chunk of data, we've looked through it, we've had a look at features that might be useful from our exploratory data analysis, and we might want to start creating some features, so doing some feature engineering. So based on the features that we have, we might create other features. So often there's ones around time, that engineered features around time and different slices of the time, dates and times you can take. But there are also more kind of complex ones, or ones that are kind of specific to a problem. But there are also ones that are kind of common in the industry as well. So the Charleston Comorbidity Index, to name one. And there's a lot that you can kind of explore in literature if there's any kind of established engineered features that could be used that are relevant to your problem. But also when we are generating those features, can we use those when we deploy our model? So is it possible to create those in real time based on the data that is being sent? Is it something that can be done that kind of, if you do some data engineering before it's sent to the model, can it be done there? And so those kind of key considerations. So say we have our data set that we have curated, we've checked the quality, we've checked the missingness, we've engineered some features, we can start to try out some models. So again, through an iterative process, we want to do some tuning, some training, and evaluate those models, and see if we can improve the performance. And so sometimes also really useful to communicate with clinicians or stakeholders to understand the data or the process that they go through if it's predicting something that they might think about themselves, understand what they think is necessary, especially if they're kind of subject matter experts. You know, we can use that and see, is our model missing something from that? Do we need to go back and collect some more data or engineer some more features, and try different and try again with our kind of model training. And also we have a model and we have trained it, we've evaluated it. What's the most important metrics to consider? So we spoke a bit about how we might define that in the problem review section. So about how we might think what are the risks involved with false positive, false negatives. So we might want to optimize against these. There might be other performance metrics that we want to check against. And also making sure that we can explain those in a way that our kind of stakeholders who might be non-technical can understand. So making sure so that they can have the full impact of what the model can do and understand how it can be best used. So we've created a model, we've iterated through, and we've created one that the performance of is possible to be deployed. And so it's ready to be used by stakeholders in the end case environment. Once we've deployed it, we might also want to think about monitoring the model. So our models are trained at on a data set at a point of time. And you know, we spoke about how healthcare evolves over time, and that means that the data could also drift over time if something that we are using as our inputs is changing. So we can monitor the data to understand, actually, is this different to the data I trained on? because my model works at a certain performance on the model on the data it was trained on. But if this data is different, that's going to impact the performance. So you might want to monitor. And then if, say, that monitor does say, oh, the data that the model is getting now is different to when you trained the model, you might want to start to think about retraining, and kind of all comes into something called like ML ops. So around monitoring, retraining, and redeploying a new model if required. And that is kind of the key aim of that, is to keep the model working at the expected performance and make sure that it's not degrading. So once we have the model, it's deployed, we're monitoring it, we're making sure it's staying okay. We want to embed it into the kind of the end user environment. So we want to make sure that we communicate the model really well with stakeholders, so they understand how it can be used, how best to use it, and what they might want to understand, what's going into it, and make sure that they kind of understand the outputs and how the process of it's going to be monitored to make sure it's working. But it also might require that they need some, process changes to use the model, or they might want to or kind of any kind of change management of how best to use the model, and more broadly be adopted by everybody. And also a key part of this is we might want to explain present the explainability kind of elements of the model around what features are most important and things. And so we've spoke a lot about creating a model and some of the constraints within the healthcare data, and how we might work towards those. But we also have to we haven't touched on this quite so much yet, but we also have to consider the ethics of the data science that we're doing. So there might naturally exist some bias in the historical data, any kind of systemic error or bias that might exist that might affect the clinical decisions or patient's outcome. And just these might have existed in historical data, and so when we're thinking about creating a model on this historic data, we also have to consider that it might perpetuate some of this bias or kind of into our models. So what you might want to do is kind of do some analysis on some of the features that might do it, that might perpetuate bias, and just make sure that that the effect is minimal. It's a whole another topic on its own, which so I won't go too much into the detail, but we want to kind of understand exactly what data our model is using and what it is outputting, which brings me on to explainability. Data science, AI, and the algorithms that are used can sometimes be seen as a black box to end users or people that don't work with them regularly. So it's useful to kind of build into our models and our deployment of models an explainability component. So because it helps build the trust and therefore the adoption of the models, which is always the key. A lot of data science projects don't always make it into being in production, and so things like this can really help with the adoption of using these models. And they want to be because people that use them want to be confident that it's being fair and it's been done in an accurate way. So a popular route for this is using SHAP values. And so there are a few different routes you can look at with SHAP values. So the first would be kind of global interpretability. So this shows how much a predictor contributes to a model. So if we can take a look at this graph, this model is just from the SHAP documentation, and it uses a bunch of features, and it shows us that age is actually a really important feature in this model, and then we go down as to ones which are less important, and it helps our stakeholders understand what features are in the model, how it's used by the model, and how important it might be. And then there's kind of local interpretability. So the global one thinks on a whole, like if we consider all of the data that it's trained on and all the aspects that the model has in it, these are the importance of the features. But when we think about local interpretability, we might want to look at just at a single model input and think what values were put into the model, and how did it come out with that output. And so the local interpretability breaks it down for that individual person. So because this input was this age, because the age here was 65, it had a big impact on the output being 0.4, and so on with these with the other values. And so this kind of local interpretability can really kind of bring it back to these values have been inputted into the model, and this is why you've received this prediction. Press the wrong button. So I think I actually went through that a bit quicker than I had rehearsed. So I can thank you for listening, and I think hopefully you've got an idea of data science in healthcare, and how we can do topics and projects with this in the industry. Yeah, thank you very much.
Thank you very much, Emily. That was a great introduction to the field. Everyone, please feel free to post your questions in the Q&A. We have time for a great discussion. So I'll start off with one question that someone asked. So are there points in this process where you need to consult with a medical team to get info or adjust the direction of the model?
Yeah, no, so I think it's really useful to involve kind of the relevant staff. So that could be clinical, depends on the project you're going for, but if we could think about stakeholders, so the end users or people that the model might affect, it's really key to get their involvement throughout the process. They are often kind of subject matter experts on the area that they're doing. So having an open communication with them throughout is really key. You can understand more about the data, the processes around it, and I think it's key. Yes, there are big parts where you might discuss kind of the overall performance, or you might discuss kind of where to start looking for data, but there are elements throughout the whole process where it's useful to keep checking in with the stakeholders.
Great, thanks so much. Let's move on to the next question. So someone says, thank you for a great session. And it seems like knowledge of medicine is important in healthcare and data science. So do you have any advice for those who want to break into AI in healthcare but don't have background in a medical field?
Yeah, I think there's a lot. So for me, I came into it from a so my kind of my degrees both in mathematics, and so I kind of came into it just through kind of like project experience, but also doing lots of reading around of other projects in the healthcare industry. I did some courses online around kind of AI and in data science. So, and then once you're in there, kind of that communication with stakeholders really helpful to understand more about the medical component, and also just keeping, it's a ever-changing environment, so just keeping on top of things like the articles being published, or in a specific topic of healthcare that you're interested in, just keeping an eye on kind of news articles and things. That's the way I've done it, at least.
Are a lot of your coworkers, do they have a strong medical background, or are they mostly coming from the data science side of things?
It's a mix, I think. So some have come through a medical background, and some have come through a kind of mathematics, computer science background, and kind of become more specialized in the area by doing work in the area and doing their own kind of research and learning outside of the project work that we do.
Great. So it seems like there are a lot of opportunities for people in the audience who are interested in this field.
Yeah.
Someone else asks whether you have any favorite free sources of data to practice this sort of analysis or modeling on.
That's a good question. I know there are a lot of kind of data sets out there. I haven't used any free ones, I don't think. I think there's on I sometimes check on Kaggle. There's occasionally some data sets on there, along with a kind of interesting topic. So you can check there, and I believe there are some that are free for kind of researchers, if you're aligned with like universities and things, but I'm not 100% sure.
Yeah, I know it's difficult with the privacy concerns with human data. I know in my experience, if you're interested in practicing on like animal, like mouse data or things like that, they're usually a lot more freely available data sets because the privacy isn't a concern.
Yes, that's right.
So someone else is asking, what are the upcoming trends, technologies, practices in healthcare, in data science? Like in the next 3 years, what do you think will get big, or what's getting popular now?
Yeah, I think it's, as we already said, it's growing, and I think there's a lot of things that are getting quite popular. With the wearables has been like, it's been a bit of a phase recently, and I think that's already been growing in the since more and more people are wearing kind of those digital devices. There's also kind of trends in the kind of like computer vision ones, so medical imaging, and advancing in that. And then I think around kind of digital, if we're thinking like digital hospital wise, so kind of either like digital twins or just kind of digital products that enable better like efficient care through the healthcare services, especially with all the current challenges around that.
Can you explain what a digital twin is? I think I've heard the term before, but
yeah, it's quite a popular term at the minute. So around kind of having a kind of, well by the name, kind of like digital replica of and it's not always hospitals, but digital replica of the thing that we want to twin of, and the ability to kind of, and a lot of them are either the ability to kind of simulate the events that might go through, that might happen, and you might be able to change different things, or understanding or kind of showing the flow and of things through, and being able to tweak and simulate different conditions that might happen, and inputting kind of what the real data might show in the future. So things such as forecasting also lead into kind of the digital twin sort of idea.
Great, yeah, that's super helpful. Thank you. So another question, what is the best approach when dealing with issues of governance and compliance for data that would cut across different countries in the age of medical tourism?
That's a good question. I guess kind of have to we'd have to understand the data constraints in all of the countries that you're thinking of. Yeah, it's a big minefield, or the kind of the compliance for the different places, but yeah, it varies a lot. But I think there's a lot of kind of baseline rules that apply in all of them, but yeah, if you've got it going across multiple countries, you have to kind of consult, I guess, each country and see what their privacy is, and I imagine go with the max, kind of the one that's the most constrained.
That makes sense. Yeah, definitely makes things more complicated with all of these things. So another question, which programming language and cloud, like AWS, GCP, Azure, do you see as most prevalent in healthcare data science projects in the industry?
That's a good question. So in my experience, it's been a bit of a mix. So I know that like a lot of the big cloud companies are introducing their kind of health capabilities, and a lot have been released even reasonably recently. So there's a lot of capabilities in all of the clouds, I believe, around healthcare. And in terms of languages, I've always used Python. That's just personal preference. I know that R is quite prominent in kind of in healthcare settings, so especially with people that have come from a medical background coming into data science, that's in my experience they have used a lot of R. Yeah.
Okay, great. And I think I'll ask one more question. If other people have questions, feel free to put them in the chat. Otherwise, after this question, we'll move on to the next workshop. But what do you think have been some of the biggest challenges for you in your work, especially just in the AI healthcare space?
Just like general challenges, or?
Yeah, I guess like, do you think it's like building the models themselves, or getting access to the data, or obeying different government ordinances, those kinds of things?
Yeah, I mean it's often a challenge to get some of the data. Yeah, and often I think a lot of the challenge has been kind of data, getting the data, and then and I'm not going to say this is specific to healthcare, but it's also with all the cleaning, it's always the longest kind of task, as we can imagine. So yeah, probably those are kind of the biggest challenges. And I think just making sure that keeping on top of as well, if there's any compliance or kind of checks that need to be done on the kind of data science models before they can be used, because some more and more countries are bringing in kind of restrictions, not restrictions, but kind of checks like compliance and governance around your data science models if they have like a clinical impact, which naturally makes sense, but kind of keeping up with those is really important.
That makes a lot of sense. Thank you so much for a great session and for answering so many questions.
Thank you.
Really great to have you.
Really great to be here. Thank you very much.
Thank you.